Hey everyone, in this video I'm going to cover basic package management using the DNF package manager. This is a default package manager used by Red Hat and clones, as well as other RPM-based distributions. RPM packages contain the program to be installed along with metadata and files required for the install. While the RPM command can be used to install and upgrade packages, it presents challenges similar to those of the dpackage command on Debian systems. RPM is a lower level tool that is a bit more difficult to use for some tasks and also lacks the ability to perform certain functions like automatic dependency resolution. This video will mostly skip covering the RPM command. I do recommend learning more about it, and there are some functions that can only be performed by directly using the RPM command. DNF is based on Yum. The primary reason DNF was created was due to Yum issues and limitations that could not be easily resolved. At least for distros based on Red Hat, I think as of 8, DNF is used by default. Distributions that have fully migrated DNF, you can still use Yum on the command line since it's a link that points to the DNF executable. And we'll just check that out right here. And we can see that we are pointing at DNF. And so DNF caches data about configured repositories, including data about newer versions of installed packages as they become available. The metadata will be considered expired if the time since the last check exceeds the meta underscore expire setting. DNF commands will run a check by default to determine if the local cache is expired. If it's not expired, the local metadata is used as is, and the command will provide output detailing when the last update occurred. If it is found to be expired, the system will reach out to the remote repositories to update the local metadata. By default, some DNF commands will not perform this check and will use the local metadata even if it's expired. Usually it's possible to pass an option with the DNF command to invert its default behavior, meaning to either force or skip the refresh. Let's take a look at updating package. So once the metadata check is done, the system determines if an update is available. If there is, the output will provide some information about the actions it will take, like the list of packages / dependencies that will be updated, and prompt the user to enter yes or no to proceed. We can add -y to the command, which will assume yes and proceed without prompting. And so in this case, notice that the system did provide information showing us that each repository that's configured was updated. So we did update our local metadata cache. And so now that we've seen what happens when we try to update a specific package, as well as what happens when we need to refresh metadata, let's check out how to update all packages on the system. So we can do that with just the update command. And the difference here from what you see on Debian is this command will actually run the update of the packages themselves, not just the cache. And so we have quite a few packages here. I'm going to go ahead and let these update, and then we'll come back. So now that we've run all our package updates, there's one quick thing we can check out here. And notice that if I do a update again, we see the information about our metadata check, and it doesn't actually go out and do anything because it's going to use the local cache because it's not expired. So if we do want to force that to refresh, we can add the refresh flag, and that will force it to go out and make sure we have the latest metadata. And of course, we can also just check for updates, and then we can decide if we want to install them all or not later. So we could do a DNF check-update. And of course, we'll use our local metadata because it has not expired. And since we just update, there's nothing to get. So that's a way to check without actually performing the updates. Again, if you do run update and you just want to update, you can pass -y and it will skip prompting. I also want to point out another detail about the local cache is that we've been running with sudo But regular users can run informational DNF commands, but they wouldn't be able to run commands that perform changes. So without running sudo to run DNF as root, I can, for example, run check update as my user. And even though I just ran commands with sudo which caused metadata to sync, when I run as my user, the system is reaching out to the remote repositories and it's caching data. And this is because the cache is per user. The instance of the cache created when root runs the command is considered to be the system cache. When running as a normal user, the cache only option can be passed to use the system cache. If the cache only option is passed when running with root privileges, it will use the local cache even if it's expired. So keep that in mind as well. And before I continue with installing and updating packages, be aware that DNF might return errors when attempting to install or update packages due to issues with the local cache. In some cases, running the clean command will resolve the issue. And there are multiple options that can be used with clean to target specific files that are cached, or all can be passed to run all clean operations. While there may be instances that are appropriate to clean specific parts of the cache instead of using all, I'm just going to demonstrate clean all here. Check out the man page to review all the options for cleaning. And so running as my user, and we see that we get 25 files removed when I run like that. But if I run with sudo, it's going to target the system cache. And so even though we cleaned with my user, now it's going to clean the system cache if running with root privileges. So you just want to be aware of that and remember to clean the appropriate cache when you're running the command. So back to managing packages, let's go ahead and install a package here. And so we'll do a DNF install net tools. Since we just cleaned the cache, it's going to update it again and store it locally. We'll go ahead and say yes. And then we can also reinstall a package with the reinstall command. If we're having problems with an install, we can try this. See if it resolves our issue. And so to install a package from an RPM file, DNF just needs to pass the RPM. In this case, I'm going to specify the download command with DNF to download instead of installing. And I'll use the download dir option to make sure to place it in a specific directory. Otherwise, it'll be placed in the current working directory. And download. And notice that we can download as a regular user. And since I cleared my user's cache, the system again refreshes. And I just want to drive that point here to illustrate that this is normal behavior. And it can be kind of annoying. So you may want to use the cache only option when you are running as a regular user if you know the system cache is up to date. Otherwise, you can still just run your commands with sudo. And so back to our RPM file, I can install the package by providing the path. In this case, I only downloaded the Samba package itself. So when the command is processed, the data in the RPM file is checked to determine dependencies. DNF resolves those dependencies, which will retrieve and install them for us. So we don't need to do anything there because DNF will take care of it. So if we wanted to download all related dependencies to that package, we could also use the resolve flag. And that would also grab all those dependencies as well and download them. So that's an option too, if for some reason you need to get all the files over to a machine and to install them from there. And of course, to remove, we use the remove command. And that's going to go ahead and take care of uninstalling all the dependencies for us. And of course, you can also pass -y with that command to skip the prompt. And the behavior we get as far as clearing all the packages that are no longer needed are controlled by the clean _requirements _on _remove setting in the configuration file. And this is set to true by default. And so now that we have the basics of updating and installing packages as well as removing them, I'm going to go through some additional commands that are helpful for getting information about packages. So to get more information about a package, we can run the info command. And if it's run without specifying a package, it will return a list of all available packages in the system's configured repositories. By default, info does not cause metadata to sync, so the info returned may be outdated. The info command can be limited by listing installed packages by using the installed option. So we could do something like this to run through our list of installed packages. And just to demonstrate of things we have installed, roughly, there's our packages installed. And then we could also see everything that's available, or I would say the number of available packages from all repositories. So another command that's useful to get information about packages is the list command. It does not return as many details as info, and it works well for returning a simple list of all installed packages. Let's go ahead and just check out how that's formatted here. And so if a package is not specified, the command will list all available packages like info. The list command also takes the installed flag. List does not cause a metadata sync, so keep that in mind. And there we'd have a list of all installed packages. So list and info if the name works well, if the name of the package is known. The exact name isn't known. Piping a partial name to grep could work to filter on partial matches. But the search command might be a better option if the exact name isn't known. Search also checks the text of the package summary, allowing for broader searches related to general functionality, specific protocols, or other details. So, for example, something like this. And as shown in the output, the results are grouped based on where the match was found, like list and info. By default, search does not perform a sync. So now that we have the tools to get additional information about packages, I want to cover another way to install packages with DNF. Virtual collections of packages that are referred to as groups, which contain multiple packages that are generally related. So to view the available groups, we can run, and there's what's available with our configured repositories. And so to determine which packages are part of a group, we can use our info command. And then we can see everything that is associated with that. And then I can install using this command. Or I can prepend the name of the package group with the @ symbol, and I can skip the group command. So I could do it something like this. And that would work as well. With either method, I could remove the group by replacing install with remove in the command, and that would take care of that. So I'm moving on to the configuration file. It's located in etcdnf. I'm not going to get into much detail as far as the specifics, aside from a couple things mentioned related to the default behavior of some commands. The descriptions of all settings can be viewed by checking man-dnf.conf. So let's just take a quick look at this in its default format. And so this is all the default configuration after install that we see in the file, but it's not all the default settings. Those can be reviewed by running the config manager command with them. So we could do this. And now we can check out all the default settings that are going to be applied. And by the way, config manager command is actually from a DNF plugin. I'm not going to go into much detail about plugins, but in this case, config manager plugin is part of the DNF plugins core package, which is installed by default as part of the core minimal install group. There are additional DNF plugins available for install to extend other functionality as well. And so now let's talk about repos and keys. So similar to apt and Debian-based package management, we also have repo files with DNF. Before I get into the location and composition of those, I just want to point out the setting. And so this will expire metadata if the repo file is changed. It won't expire all metadata, just the repo or repos configured in that file. And that is enabled by default. So if you do make a change and then the next time you run a command, it should force a sync. All right, so let's check out our default repositories. And repositories are configured in etc yum.repos.d. And those files should end with .repo, otherwise the file will be ignored. The name and structure of the files here will depend on which distro you're using, while the base OS and AppStream repos are the primary enterprise Linux repos, depending on the distro. These may all have entries in the same file, or they may be split up into different files. For example, on Rocky 9.4, base OS and AppStream are configured in a single repo file, while Alma 9.4 places base OS and AppStream in their own separate files. And Fedora looks a little different, using its own naming and structure for its repos. I'm going to use Rocky for this demo, but the general concept should be adaptable for other RPM-based distros. There's what we have by default. And so this file contains the primary repositories as configured with a minimal Rocky install. In this instance, the file contains multiple repos, each separated within a section, containing the name of the repo within square brackets, followed by settings. Before I go through the settings, notice that there's some variables used throughout the file. And so we can use Config Manager to list out our variables. And there they are right now. For a complete explanation of the predefined variables and information on setting custom variables, check out the dnf.conf man page. So back to our repo file. The first entry here for base OS refers to a repo containing packages that provide core OS functionality. Here, the mirror list field contains the URL pointing at a list of mirrors serving the repo. Using mirror list should do some magic behind the scenes, resulting in a decent mirror being picked. Using mirror list also increases availability since it works with multiple mirrors instead of just pointing to a single URL, or I should say a single mirror. Not shown in the configuration file, the metalink setting can be configured to point at a mirror URL. Without getting into all the details, metalinks have extra checks to help avoid stale mirrors and provide a more secure method of serving a mirror list to clients. There's also a base URL commented out. Multiple URLs could be added to the base URL line, and then they are tried in order. The GPG check setting is enabled for this repository. Will verify the signature of packages from the repository. Skipping to the GPG key setting, this takes a URI which the key can be imported from. In this case, it's stored on our system. I could add a new repo, and though the URI may point to the appropriate key, if it has not been imported into the RPM's key store, it will prompt to import the new key if I attempt to install packages from that repo. I'll demonstrate that in a bit. Sometimes there might be an issue with the key that causes DNF to refuse to install or update packages from the associated repo when GPG check is enabled. And while this can be bypassed with the no GPG check option on the command line or disabling this in the repo file setting, I don't recommend it. Instead, the old key can be removed so that the new key can be imported. I'll use the RPM command to list out and remove the key. And while this video isn't going to get into the RPM command in depth, and I'm not going to get into a lot of details about key management, I'll very briefly demonstrate how we can check our RPM keys. So first, I can return the keys that have been imported. And so we just have the one here, so it makes it pretty simple, so we don't really need to check it because we know which one it is. But if I want to check to confirm that, there are a couple different ways to filter and enumerate the details here. And so in this instance, I can use QI. Then I get all the info right there, so I know which key it is. And so if I use the -E flag, I can get rid of this key by removing it. And now when I try to install a package, I get a prompt after I go ahead and OK it and ask me if I want to import that key. So in this case, I just removed it from the RPM key store and imported it again using the existing file to demonstrate. So if an actual problem presented itself, I'd also need to make sure I copy the new key file to the location set in the repo file or point at the URL path of the key file. So now jumping back to our repo file real quick here. So back to this list of settings, we have enabled, which is set to 1 on the base OS repo. The other base OS repos here are base OS debug info and base OS source, which are disabled by default. So repos can be enabled and disabled on the command line by passing the repo ID. And here we can now see it is set to 0. And now we're set back to 1, so it's enabled. So now we have the count me setting, and this is used to help repository owners estimate the number of systems consuming it. Check out the man page for more details on how all that works. The repos here are using metadata expire to override the global setting defined in dnf.conf. The upstream repository, which is also enabled by default, contains packages to extend functionality beyond what's contained in the base OS repo. The extras repo is also enabled on Rocky, which in this case is used for some additional functionality to avoid breaking upstream compatibility, as stated on their website about their repositories. So check out the DNF man page to review additional settings that can be applied to the repos here in the file. And so now that I've gone over the default repos configured for a Rocky 9 install, let's check out adding a repository. I'm going to use LibreWolf in my example. They make it pretty simple by supplying a command to download the repo in their install instructions. I'm using the instructions for Fedora. It doesn't explicitly state it works for RHEL and clones, but it works on Rocky. I'm not using the exact commands that are given in the instruction to download the repo file, but it doesn't matter. The important part is that I have the repo file in the correct location with the correct information. Also remember that I can modify the repo file to override the defaults. Let's check out our repo. Let's go ahead, install. So the prompt to import the key outputs a fingerprint, which matches the keys listed in the instructions on the web page, as I verified prior to setting this up for the video. And so now once this is complete, it will be installed and ready to go. The last thing I want to cover is using the history command to get a summary of the DNF transaction history. There are also several functions that can be used to revert and reapply updates. I won't be covering those much in this video. You can check them out in the history section of the DNF man page. So we'll start by checking out the transactions. And that's just history. And so first we get the ID, which is required for some history commands. You'll actually have to pass that transaction ID to perform any operations on it. The command line will show you what was run to perform any transactions. The actions will give us some information about different operations that were performed when the transaction was processed. If multiple actions occurred, the identifier is abbreviated down. They're listed out on the DNF man page, but we'll run through them right here since we can see some of them, like I is install, a new package, E, remove a package, O, obsolete a package, meaning a package was replaced by a new package, upgrade a newer version of the package, replace the previous install version. Package, R to reinstall a package, and then we have the reason for the change, or C. And so if a package was kept in the system, but its reason for being installed changed. The altered column provides information about the number of actions taken during a transaction. Some of the transactions may have additional specifiers in the altered column to identify conditions that occurred. So the greater than, the RPM database changed outside DNF after the transaction, less than, the RPM database changed outside of DNF before the transaction. Then you might see an asterisk. The transaction aborted before completion. The octothorpe or pound symbol. Transaction completed but with a non-zero status. E, transaction completed successfully but had error or warning output. And so to get the specifics of a transaction, the info command can be used. So if we did something like on transaction 8, this will provide more info about the transaction, including a nice list of all the packages that were altered during the transaction. So let's just look at our list again. And let's check out an upgrade transaction. And so in this case, we get a pretty detailed list, or actually a pretty big list of everything that changed because we updated all the packages on the system. And so this is helpful for doing a review of all the changes. It's formatted and trimmed down. And we can also get this information from the DNF related logs in var log. Of course, we'll have to search and filter and format those ourselves if we do search through there. And so that's it for this video. That should get you started with using DNF to manage packages on your system, as well as working with the repo files. DNF has a ton of functionality, and I've really only scratched the surface here. If you found this video helpful, please leave a like and consider subscribing to the channel. Thanks for watching.